Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Meredith Chaiken and Seth's brother Joel. That we're here to hopefully show you how to approach SAT Math questions and then also maybe how to approach studying for the SAT Math. We are now doing the Khan Academy questions, which we highly should encourage you to take because Khan Academy tells you basically what's on the SAT, and it's wise to do every problem in Khan. There are about 700 or 800 problems. They're organized in 40 topics and 20 questions per topic. Today, we are at the highest level of table data, so we're going to do question 16 out of 20. The 16th most difficult question out of 20 in this topic called table data. Okay, please read it, try it, come back, and we'll do it. And you can see how we're approaching it. Okay. Biologist conducts a study regarding an invasive species, the gupta fly, in the city of Porto, Brazil. The flies were sampled from 3 different parks in over 2 years. Okay, based on the information table, that's very important. Don't make stuff up. What is the approximate probability that a randomly selected gupta fly sample from 2001 was found in either the botanical garden or let's change, no, let's not change color, just make these darker, or these guys, right? Or, it's an or, right? These guys. So what's the probability that these two things together divided by the total, they're basically asking for that, right?
Yeah.
Right? They're asking for 2604. We have to assume this is a calculated question. 2681 divided by this number, 2604 plus 2681 plus 2640. Right? That would be the answer, right?
Now look at now compare the different choices of responses.
Okay, 33.
Do we have 50? Only 4 of them? Up A through D, or are
no?
We not
Maybe an E. No, there wouldn't be an E. No, they wouldn't be an E.
So they're just 4 of them. Okay.
Yeah, just 4.
Well,
just 4.
First, now the approach to it before starting a messy calculation like that. Look at the choices.
True. Yeah.
Now notice that they differ from each other by quite a lot. They differ.
Right. Yeah.
By 1 digit. This is a 6.
Right.
And this is a 7. Those 1 digit out of less than a range of less than 100. So they differ by, these are more than 10% difference.
Right.
Now, how much makes a 10% difference in the numbers we're looking at here? These numbers, all of them, it's easier to see from the table, all of them are 2,600 something. Right? And the biggest variation is less than 100 between 2 numbers.
That's right.
10% of a number that's more than 2,000 is 200. Right? These numbers do not differ by as much as 100.
Right.
And so you could approximate all of these, all 3 numbers as approximately 2,600.
Or as the same number like I did.
As the same number, 2,600 plus 2,600, which is 2/3.
Right. Yep.
So bingo, 67% is the answer.
Right. So all saying
77% is just too far away from approximately 2/3.
Right. So basically, Seth's basically saying all these numbers are basically the same. So you would want to look for a pattern. So much of doing the SAT questions involves looking for patterns so that you can get the answers faster. But there are 2 components to this question. One component is you got to know what probability means, right? You got to know what they're asking. You have to know how to set this ratio.
And you also have to know to restrict your calculation of the probability to the 2001 data.
Right.
In
That's
other words,
yeah,
ignore the 2002 data.
right. So that's the substantive part of the problem. Then you once you write that, then you have the calculation pattern to get to the answer as really as fast as possible.
Mm,
So you can
yeah,
definitely cut corners on calculating, but also this is called a conditional probability question, isn't it?
yeah, yeah.
Yeah.
Well,
So you have to use common sense with these. Probability isn't heavily stressed that much these days. In fact, when we went to school, it wasn't stressed at all. There was zero probability was taught. Now it's a small part of a math curriculum, but you have to know what this means in order to do these tests. So you have to practice probability and table data when in practicing. But the bottom line is probability is accounting of what what basically what you want over total. Seth will be better because Seth's an expert in probability. I'm not. What you want over total things. I mean, this is so wrong, right? This is so not. This is so wrong what I'm saying. But it's the idea is that you want to count the number of occurrences that you want to count that you're asking for, right? Divided by the total number of occurrences of everything.
yeah. Well, the particular words that are used to talk about probability are sample space, element of a sample space, and event.
Yeah, I know, but once we start talking about that, you may
Well, people are taught those words. So shouldn't we not review what they mean? You know
sure,
what
but
your things. So I will insist on saying
go ahead.
that the total set of things is called the sample space.
Okay, so let's do it right. Sample space.
And
Okay.
then you formulate a subset of that,
Yeah.
which Joel calls what you want.
Right.
That
Really,
subset
pretty
of
embarrassing.
what Joel says what you want is called an event.
Okay, an event.
And then what's associated to uh, an event, a sample space, and what's also needed is the given probability distribution. What's associated to an event and a sample space with a probability distribution is the probability of the event,
Right. Good.
which is the probability that the event occurs.
Right.
Now, when all of the elements, the things that Joel talks about have a distribution of equal probability, then the probability of an event is the number of things in the event divided by the number of things in the sample space,
Right.
which is the number of those things that Joel wrote, the number of what you want, and then the total number of things.
Right.
So that's what we did. So here, the things are the flies. Each thing is a little, or maybe even a big. Each thing is one Gupta fly. There are how many? 3 times 2,600, about 8,000 Gupta flies in the sample space. The event that we're interested in is those flies that were collected either in the botanical garden or the Farwick Park. Okay, it's assumed that that a fly is chosen from the collection from 2001. Each fly has an equal chance of getting himself or herself chosen. The probability is therefore the total number of flies we're talking about from the 3 parks collected in 2001 divided by the number of flies that came from the first 2 parks.
Right. That's right. Yeah. So, but
And
you have to.
I got it upside down. The total number in the denominator is, and then so the probability is the number of flies from the first two parks divided by the total number of flies from all three parks.
Right.
Restrict only from 2001.
That's right. So you have to be careful to restrict it. To restrict it. To restrict it. Um. Wait. There's something else that's important. That comes in probability questions that I'm sure most people have seen, but it's really an important consideration. Is the word or, or. This means both botanical gardens or the F park, let's say, right? So you need to, if it's an or, that means you need to add the two because it could come from one or the other, which means that you have to consider both when you're counting the number of flies that basically pass the muster that are in your event, or basically what you want, what they're asking for, which is basically the flies in the botanical garden or the F park, right? Yeah, yeah. So the or means you have to add. Well, I don't think we're going to go more into probability, make things more complicated. That'll come in another question. But yeah. So that's basically how you do the problem. There's no
Okay,
shortcut.
What's the probability that a fly was chosen that came from both? One fly was chosen that came from both the botanical garden and the Farahalla Park.
What do you mean? Both. You mean the fly? You mean the fly was first caught at botanical garden, and then the same
No, I
fly?
mean that it's a fly. Yeah, no. What if I said probability that the fly that you picked came from both the parks
Wait, you made it at the same time?
at the same
Well,
time? Yes, yes,
zero, because a fly can be both in the
yeah,
botanical
yeah,
garden and the F park, which means that when you read probability problems, you have to understand what's going on in the situation,
yeah.
right? It's impossible for it to be in both, but it could fly from one to the
But the
other,
probability is meaningful.
right? Yeah,
Yeah, so an event could be the empty set,
right. Yeah, yeah, yeah.
in
It could
which
be
case the
zero,
probability is zero.
right? Yeah, yeah. I guess that's it for from. Oh yeah, yeah. So I was just to say, when doing this problem, I don't think there's any shortcut in formulating this idea. Right? There's no shortcut. Like you can't just look at this and say, "Oh, it's 2/3." You got to think this through, right? You got to formulate that. Yeah.
I did it by just looking at the table.
No, but you did it at the table by doing this very quickly in your head. Like there's no other way to get the answer than to make this calculation either in your head or on the paper. Is that correct? There's no shortcut to getting the answer. You got to just put in the definition. You got to just do the calculation, right?
No, you just observe this is a number. These three numbers
Yeah,
are very close to being equal.
right,
So you think of them as globs.
right. Yeah, as
And
I
so you
call them,
have a one
Z's.
glob
Yeah,
divided by, you have two globs divided by three
yeah. But
globs,
the
which is
fact is,
two-thirds.
you set up this division. You set up
Yeah,
this.
yeah, sure,
Yeah,
yeah,
yeah.
yeah,
That's what I'm saying. That's what I'm saying. Okay, so
yeah,
I think we're done. Today's Throwback Thursday, which means we're going to go back to a question before the 2016 SAT, when there was no such thing as con, and when there was no such thing as this. There are
yeah.
40 topics on the SAT. Before 2016, it was anything went. Anything went. The possible any question you could have seen, and a lot of the questions were more of an IQ reasoning type question. So let's go back and see what a question would have felt like in the early 2000s or late 1990s. So here we have we have to clear the annotation, don't we?
Mm.
Clear all drawings, and we are ready to go. Throwback Thursday. Here we are. Okay, so don't be scared. This is probably not going to be on the modern SAT. Um, okay, here we go. Why don't you try it, pause it, and come back? x squared, and x cubed, line a number line in the following order shown, which of the following could be the value of x? Seems to me like x would be less than 1, right? Doesn't that make sense?
Well, look at choice B. That's less than 1.
No, I know. I mean, wow, this is a tough question, right? You gotta really think this through. I guess you could just do brute force, right? And try them all, right? 2.
Yeah, try them all.
4.
Sure.
-8. No. -1/2. No. Come on. 3/4. 9/16. God, 9/16. 27/64. 1. No, not 1. No, not 1. Oh, but wait. 3/2 is greater than 1, right? 3/2. Yeah. So it has to be this one, right? So maybe one approach after you calm down is just do brute force. But it did seem like it would be less than 1, didn't it? Because when you cube a number and square a number,
okay. You have to be precise.
I know that's my problem.
When they included negative numbers, and one of the x's is squared, and the other are raised to an odd power.
Right.
Okay. When you square a negative number, you get a positive number.
Yeah.
When you raise an odd power, when you raise an odd number, I'm sorry, when you raise a negative number to an odd power, you get it negative.
Right.
So that flips them around.
Yeah.
So squaring a negative number flips the negative number against the positive numbers.
Right.
Okay, so the number here, so they're in increasing order from x cubed to x squared to x, and so we have to keep them in the same order.
Yep.
So we do not flip any around any of the others.
Right.
Okay. And okay, but they also in the order above. So they have to stay in the same order, and the x cubed must be the smallest one. Yeah. So to stay in the same order, they all have to be positive.
Right.
And for the smaller numbers, for the cubes and squares to be smaller than the number, and for the cube to be smaller than the square, the number has to be less than 1.
Right.
So x has to be greater than 0 and less than 1, and the only one that fits is 3/4.
Right. Yeah.
So please don't say it has to be less than 1, when what's really important is that it's both greater than 0 and less than 1.
So I was pretending I was in kindergarten or first grade or second grade when I didn't know anything about negative numbers.
Yeah. I was in kindergarten. In second grade and kindergarten, they don't talk about squaring fractions.
But they also don't talk about negative numbers. So I was crossing to both.
Yeah. So if you so among the positive numbers, among the positive numbers, we have to choose between exactly 1, greater than 1, which is 3/2, and less than 1.
Right. Yeah. So this question has many questions. At first it seems a little intimidating, but when you sort of read it a few times and think about it, it's not that bad.
Yeah.
Yeah.
Okay. Now. Yeah. So actually, you wrote your 3/4 here, and then what's that?
9/16.
9/16. Notice that 9/16 is less than 3/4.
Yeah. 9/16 belongs to be here in 27/61. But let's say you wanted to. But the other way to argue it is if you have 3/4, right? and then you multiply by another 3/4, you're multiplying by a number less than 1. So this product has to be lower than 3/4 because you're
Less than.
multiplying by a number less than 1.
Okay, why is that? Suppose you have a pie and you have 3/4 of your pie. Okay.
Right.
And then if you take 3/4 of that, let's say a quarter of the pie. Let's try to divide this pie into quarters. Is about a quarter of a pie.
Yeah, that's about a quarter of a 3/4. That's about a quarter of the red region. Yeah.
Yeah. So here these are equal. I don't know. This looks a little bigger. There's a quarter. Each of these is a quarter of the red region.
Of the red region.
The red region is 3/4 of the pie.
That's right.
So 3/4 of the 3/4 of the original pie is less than 3/4 of the original pie.
Right. That's less than the red region. The blue region is less than the red region.
The blue region is 3/4 squared.
Right. 3/4 of
and the
3/4.
and the red region is 3/4.
Right.
And the whole region is 1.
Right. So that's why, like, if your brain is fried, which will happen on the SAT, this is already question 19. If you're asked immediately, just boom, without even thinking, what's bigger, 3/4 or 9/16, you may actually sit there and have to think a little bit. But if you think about this way, and then, right, this uses up some computation power. But if you know that 3/4 times 3/4 has to be less than 3/4,
Okay.
then you don't have to waste your time even asking yourself.
Okay. Well, even
3/4
thinking of 9/16 is a waste of time.
Okay.
Don't think it's 9/16. Think of
it
the
as
number in question as 3/4 squared.
Right. Yeah.
It's a square of a. Think of it as the square of number x, where x is a fractional, an ordinary, non-trivial positive number fraction.
Right. In other words,
which means ordinary, proper. Okay, there's a word for it in elementary math. It's called a proper fraction.
Okay, a positive.
A positive proper fraction between 0 and 1.
Got it.
Numbers between 0 and 1, when you square them, or in fact, if you take any two numbers that are greater than 0 and less than 1, you multiply them together, you always get smaller numbers.
Right. Yeah. That's just
like 1/5 or 7 or 4/5 times 7/8.
Yeah.
That is smaller than 7/8. That's smaller than 4/5.
This is something to really remember and really know. This will come
up.
I
don't. I think a lot of kids don't know this.
You're right. It is something to really put in your heart.
Something that comes, don't be literate in numbers.
Yeah.
I bet a lot of people simply don't. Well, you ask them, if you multiply two numbers that are positive and smaller than 1, do you get? Do you always get numbers that are smaller than both? They may not know. I think.
Right. Yeah.
A lot of people wouldn't realize that.
Yeah. No, that's really important. Very, very, very important.
And then conversely, not conversely, but oppositely, if you take numbers that are bigger than 1, multiply them, you always get numbers that are bigger than the original numbers.
Right. Yeah. So these are two things that are very important to keep.
Also, now compare it with addition. If you take two little numbers that are positive and add them, two little numbers that are non-zero positive, and you add them, do you always get numbers that are bigger than the original?
Yeah, yeah. Yeah.
No matter how small they
Yeah,
are.
no matter how small they are. Yeah.
Yeah. So
Yeah.
adding the adding and multiplying change relationships of size differently.
Yeah. Right. Yeah. Yeah. That's right. Very important to remember. Very important. Yeah. Okay. So I guess we're done, right?
Yeah.
Yeah, I think we're
Yeah, I
done.
guess so.
So we're done with the table question from the modern SAT post 2016. Here, and please start if you're going to take the SAT in the United States after winter, January 2024. Start doing your research. Talk to your guidance counselors because you will be taking the SAT on a computer and it will be adaptive, which means that there'll be a bunch of questions. And then based on how you answer those questions, they're going to feed you other types of questions, and different people are going to get different questions based on how you answer your first. They call them modules. So you go to the SAT, a digital SAT, and do some research on that and understand how that test is going to work. Okay, everyone. Then have a great day, and we're probably going to take tomorrow off. I'll see you next week. Okay, and of course, like us, dislike us, give us comments on directly on our YouTube videos, or email us at satmathquestionoftheday@gmail.com. And if you have any SAT math questions you'd like us to go over, please email us at satmathquestion@gmail.com. And last week we made the offer that if a teacher teaches you something and does not justify it in math class, email us and we'll feed it to the Seth, and Seth will try to justify it. By the way, Seth, I want to feed the Seth a real quick question. Let's see how Seth remembers the vocabulary. What is the definition of a counting number? What's the definition of a whole number? Do you remember from third
No,
grade?
no.
Okay, great. That's right, because it's not that important once you get into math. You don't have to worry about that. I think one of them includes zero. Both of them are zero. Both of them are positive. Counting numbers, whole numbers are the kindergarten numbers. Both of them are only above greater than zero, but one of them includes zero, one of them doesn't. And I don't remember myself which one includes zero, the whole numbers or the counting numbers. Somebody tells me the whole numbers include zero and the counting numbers do not, but it's not even worth our time looking up. But
Well, what mathematicians do,
yeah,
they do not rely upon words for that distinction.
good idea.
When
Good
a
idea.
mathematician writes on a talk,
Yeah,
the numbers, the integers greater than zero, he or she will write z greater than zero, or maybe any of the p greater than zero, or n. They'll say a common to write it this way.
But doesn't z means integer, right?
Yeah, z. Yeah, let me erase this.
Z means that's on Zyport.
Yeah, that z is used for the whole numbers, the integers, which are the whole numbers, positive and negative. But here, the to make it absolutely clear, they'll write greater than zero. They mean the non-zero ones that are greater than zero. Make it absolutely clear.
So z means integer.
Absolutely clear.
What is
P? They'll put it as sort of a footnote that is what you mean, and that if they want the ends, say they want to talk about the numbers including zero, they'll say greater than or equal to zero.
Wait. So z means integer, but what does p mean?
Positive integers.
Oh, and what does n mean?
But to make it clear that they mean exclude the zero, they'll write underneath it greater than zero.
Right.
So everyone sees that is what it is. It's greater than zero.
Right. What does n mean?
Natural.
Wait, what's the difference between natural numbers and...
The difference depends on who you talk to. It varies among people. It's ambiguous. People use it too. Various people use it. Different talks. Different remembrances of what their teachers or their parents say. And so mathematicians will usually they will be very careful to make it absolutely clear without words that people will forget.
Okay, fine.
What they're talking about.
I have an intuitive sense as to what an integer is.
It's not good enough in mathematics. But even if the simplest things, you need to have no intuitive sense exactly. You must have your intuition coincide with exactly what you're talking about.
Right. So, but between you and me, what is a natural number? What a natural number? Do natural numbers include?
Well,
things
my grade school teacher taught me natural numbers were whole numbers, not including zero. Okay. And then I ran into more advanced teachers who said the natural numbers do include zero.
But natural numbers have to all be integers.
No.
Oh, natural numbers can be like a
fraction? They don't include the negatives. Negative integers.
So a half is a natural number.
No. Integer, whole numbers. I said whole. HWHOLE.
Natural. Right. Well, okay. I meant positive integers. Sorry. I got to be precise with Seth.
You have to be precise. So they sometimes N or natural.
Wait. So these are subsets of integers.
Means the numbers that begin with 1. 2, 3, etc.
These are all subsets of integers, right? How about this?
Yeah, they're all subsets of and then sometimes other people will make N will say N is those numbers with 0 added.
Right. Okay.
And and then it's important to when you're working with numbers. Which one do you talk about?
Right, and Seth's not even including the whole numbers.
What mathematicians do, will put a subscript.
Got it.
To make it absolutely clear that in the bottom they mean include the 0.
Right.
And when they want to talk about the numbers on the top, you say greater than 0.
Right.
To exclude the 0.
So something you can count on that if you go back to your past, because in high school they don't waste your time asking whether something's a whole number or a counting number, but in grade school they may have. Rest assured that when you go into advanced math, they're not going to ask you that question. They'll make it more clear.
Yes.
So you don't have to remember what a counting number is. You don't have to remember the distinction between a counting number and a whole number. Something to look forward to.
Yeah.
Okay, great. But anyway, most people are past that distinction anyway. Nobody in high school, no high school teacher in SAT is not going to ask you whether this is a counting number or a whole number. But it could probably happen in New York State in 9th grade. It's possible. Okay, so I guess we're really done, right? Now we're really done. Now we're really done. Okay, thanks, Seth. Thank you for explaining that. That was good. Okay, it's nice when Seth gets excited about something. Okay. Okay, everyone, have a great day. Take care. Bye-bye.